Awesome. Well, thank you for joining stream, Leo. I
Thank you
super
for having
appreciate
me.
your time. I imagine most of the people here know who you are and what you do. But for those who may not know you, would you like to give a brief introduction? Or it doesn't have to be
Yeah,
brief. You can take
absolutely.
as much
Yeah.
time.
Okay, so I'll take the next half hour to explain who I am, where
Perfect.
I'm from, what it. Thank you. Hi, folks. My name is Leandro. A lot of people call me Leo here on stream, since that's a sort of shorthand of my handle, right? But the O actually belongs to my last name, Ostera, which is completely fine. People do call me Leo in real life as well. I'm a programmer. I've been coding for fun and profit for a long time, since I was a kid, mostly for fun, and then for profit since I was like 18 or so. I worked at some companies you probably know, like Spotify or Klarna, doing Erlang and Java there. And I don't know, maybe 7 years ago, I started writing OCaml and I just couldn't stop. And in the past couple of months, we've been going really hard at building a vertical slice of an ecosystem for OCaml, right? Like a subset of the ecosystem that would be very SaaS ready. So yeah, I love startups.
Oh yeah.
I love music. I love music that comes from Dylan stream. So I mostly just steal his playlists. Are amazing. And yeah, I'm happy to be here.
Awesome. So, could you also explain maybe what Riot is, what Mint Tea is, and how the 5.0 release of OCaml kind of led to enabling some of this?
Absolutely, 100%. So I think we probably want to start a little earlier than Riot. We want to start with like what is OCaml 4, right? And what happened
Yep.
between OCaml 4 and 5, and what is Erlang, right? And why those things are relevant. So Erlang is a programming language that is rather old. It's from the late 80s, and it has a very strange way of letting you build systems, right? Like today, when you go to a company, a large company, they usually think in terms of services, right? Not just tiny programs, but rather whole Docker images running somewhere, communicating with each other, right? Having their own life cycle and stuff like that. Erlang had that exact same model, right? Within a single computer ages ago, right? So in Erlang, you usually program by creating processes, which are not operating system processes. They are lightweight processes, an abstraction they came up with, right? That are super, super cheap. And you can just pin millions of those, right? And then those communicate via message passing, which is not that different from doing like an HTTP request. Like you say, hey, here's a message for you, and the server receives it, does something with it, and maybe replies or maybe doesn't reply, right? That way of building system is ridiculously scalable, right? Like it is the way that most companies at some point just start working, but Erlang had it already way before. Why? Because that way of building systems allows you to do one thing that the other way, which we'll get to in a second, the OCaml way, right, doesn't. And that is building supervision hierarchies, right? Being able to say, I'm going to create a system, a service that does something, right? And I will just let it run. And if it crashes, because it should crash at some point when something unexpected happens, something else above it will restart it, right? So you get microservices, as Ryan says, inside the virtual machine, which is incredibly powerful and incredibly fast. So people get really productive with this thing. There's a lot
Yeah.
of companies that have Erlang as their secret sauce, like WhatsApp, Discord. We've
Yep.
recently learned that Nintendo also runs Erlang for a lot of things, which is
Functions
super interesting.
describe
Now, on the other
the
side, the
world.
OCaml way of dealing with things or of thinking, right, is that your program shouldn't have runtime errors, right? So instead of embracing them, you're saying my program will rule out all possible errors, right, with a
Yep.
type system, which in practice is like 99.99% there, right? Because there's still some runtime errors, because programmers, humans and humans make errors, right? So what Riot does is leverage a change that happened between OCaml 4 and 5 that allows OCaml to run programs in multiple cores, right? Before OCaml 5, OCaml 4, you could only run a program in OCaml in a single thread, right? So one operating system. And people wrote programs in multiple cores by spinning up multiple OCaml programs and making them talk. Now
Yep.
in OCaml 5, you can say this one program is going to use my, I don't know, 32, 64 cores, however cores you have, right? And you'll be able to sort of use shared memory parallelism to make programs run across all cores. However, I don't want to do that because shared memory parallelism is hard. It's really hard to do. So we're building Riot to bring all of the Erlang model way of thinking, right? All of the supervision, hierarchies, all of the safety that message passing brings, right, to multi-core development into OCaml. And Mint Tea, on top of that, is a little library we're building, right, for doing interactive uh, terminal UI applications, right? And it's actually very small. The core of Minty is like 300 lines of OCaml, right? Super tiny, and it has a logo that Dylan made for us. Super cute, love it. So that's a little bit of like the story of Erlang OCaml and why Riot exists, right? And then Minty on top of that.
So where are you at currently in the process of building Riot, and like what can we look forward to? What can we do with it right now? That sort of thing.
So we started Riot maybe 3-4 months ago. So it's really early, right? Early days. We got a lot of cool things happening there, and a couple of people have been contributing really interesting features to it. Roughly speaking, right now you can create an application, right, that can run thousands or hundreds of thousands of processes, right,
Yep.
on any number of cores, and you don't have to think about the cores at all. So if you want to sort of run, let's say, a calculation like Fibonacci or something like that on many cores, you just call the spawn function, right, and you do something inside there, and Riot would automatically move that workload across the cores as it sees fit, right? And that means that if some work is taking a lot of time, Riot can steal that work from different schedulers and rebalance it for you. So that's something we have there. We also have typed message passing built in. So if you want to communicate between these processes, right, you have a type called message.t that
Yep.
you can extend with your own variants. And a variant is sort of like a way of constructing a message. I assume most people here know some OCaml, since this has been primarily an OCaml stream, right? But in case you don't, like that is just like a new class, I guess, that inherits from a message class, like a top level message class, right? Yeah, so we have that in place. Messages can be sent to any process on any core, and it's super cheap and transparent to do that. As long as you know where the process is, you have the identifier, you can send a message. We also have support for registering processes by name, which is a smaller feature but kind of useful. If you don't know the actual PID, the identifier, but you know, like, okay, this process is global, is registered as, in Mint we do this. For example, the Minty runner, right? We register that by name. So those are some of the core features in terms of processes. Below that, we've actually built an entire async IO stack that allows us to do things like, for example, network operations very, very efficiently in an async way. So a process can read from a socket, right, and not block a scheduler. So you can have thousands or hundreds of thousands of processes, right, reading from the network, writing to the network, opening like TCP sockets or TLS sockets, right, and just doing IO like crazy. And that is kind of Riot's first and foremost use case, right? Which is the same
Yep.
thing that Erlang does. Erlang is
Yep.
sort of like, if you want to do like heavy computation numbers, Riot is not for you in the same way that Erlang or Elixir are not for you, right?
Right.
That is not what they're built for. Yeah, I think those are some of the core features that we have. There is a standard library that we're shipping with Riot that includes a lot of things, like for example, supervisors. So you can create a process and tell it to spin up more processes and supervise them. And that comes in two flavors right now: static and dynamic. And the dynamic one is kind of cool because it acts like a pool, right? That has back pressure on you. So if you say I'm going to spin 100 things, then you can just keep adding processes there, right? Telling it to spin more, and when it reaches the end, the limit, right, it will stop, and then it
So
will tell
cool.
you, hey, I'm ready to spin something more later in the future.
You have non-goals called out in the README. What
Yes,
if you wanted to cover the non-goals of the project and maybe some kind of explicit use cases where you might not want to use Riot for an application?
100%. Yes. So as I said earlier, there is one use case that we're not supporting, right, which is the ability to run compute heavy, right,
Yep.
processes. Like, let's say you have a collection of a billion rows or something,
Yep.
and you want to process it, right, as efficiently as possible in n cores, right?
Yep.
You don't want the overhead of processes. You don't want the overhead of message passing, right? You don't want the overhead of scheduling things in and out, right?
Yep.
You want to say, I have n cores, I will have n processes, right? One for each. And then in there, I'm just going to run like a hot while true loop sort of thing, right?
Yep.
If you need to build something like that to like really, really squeeze every ounce of performance of your CPU, That is not what Riot's for. Riot is more for IO heavy workloads, right? Like you need to read from a million sockets.
Yep.
That's what we shine, right? Now, that said, there are some other things that people think about when we say like we bring the Erlang style concurrency right into OCaml, and those are things that the Erlang VM does. For example, Erlang and Elixir have a virtual machine that includes a compiler, includes a lot of like build time tools in itself.
Yep.
So you can do weird things with it, which I love, right? And they have a place and a time for sure. Like for example, in Erlang, you can decompile a module in the runtime while the application is running. You can turn that bytecode back into Erlang syntax. You can edit it, right? And you can compile it again and reload it. So the living code, right, all of a sudden gets swapped behind you, right? And then the new code starts running. And I've actually been a company like Klarna has tons of things that happen with Erlang there. And there were some situations where I've seen modules that we had the bytecode for, but we no longer had the sources because the sources got lost. So you
Oh
had a
no.
library that it was like, okay, here's the .beam file, and if you want to upload that, you have to go into the machine, copy the file. So that kind of work with bytecode, we're not going to be able to do because
Yeah,
OCaml
yeah.
doesn't quite support that right now. Which means hot code reloading, the ability to reload the code as the application is running, is not going to happen. And the other big thing that people want in Erlang and want in Elixir is the ability to connect multiple instances, right?
So that
In a
would be like
distribution.
across like boxes, or like you have two or
Exactly.
multiple EC2 instances running Riot.
Exactly. Like you would have, let's say, 1,000 EC2 instances, and you want to be able to treat them as one, right?
Yeah, okay.
That sort of thing you can do in Erlang, you can do in Elixir. It is incredibly error prone. It has gotten better over the years, right?
Yeah.
It is something that every time I write Elixir or Erlang and people say, "Oh, can we do distribution?" I say, "No," right? It is much more work than it's worth most of the time,
Yeah,
because this
yeah.
thing was initially designed for collocated machines, right? In a
Yep.
post, in a box somewhere, right? To handle telecom, sort of applications. So in that scenario, it works. But when you go to EC2 and you have two boxes, they're not going to be in the same rack, connected by one cable, right? They're
Right.
going to be who knows how far apart. Anyways, so that kind of distribution we're not going to support. It's not that it cannot be supported. I think we could look into that, but for the time being, it's not something that it's a known goal.
Cool. So Mint Tea, we're built on top of Riot, which I want to ask about. Like, what makes Riot good for building a CLI framework on top of, and then we're also built on top of the Elm architecture. Could you cover those two things?
Yeah, absolutely. So we can start with the Elm architecture. I think that'll be easier. Um, Elm as a language has, I know you know this, but for Chad, right? Oh, brilliant. You have that there already. Has this way of working, right? Where the entire application is just one function that just like continuously run. And every
Yep.
time the user does something, it becomes an event that gets pushed right into the application function with the last state. And that creates a new state to the application. And then that's sort of held until the next event happens, right?
Yep.
So it's kind of like a recursive function that just goes on and on and on, right? Um, this is particularly useful for modeling UI, I think, because UI usually is event driven, right? It
Yep.
is also surprisingly easy to implement, right, and to use. Yeah.
I want to go back and ask why
Why
Riot for
Riot?
yes.
Yeah, perfect. So I think you could build something like this just fine without Riot, right? With essentially EIO, or even without any async runtime, right? And just make something that is blocking. The reason I chose Riot was that I was writing Riot, which is I think a good reason to do it, to exercise Riot, right? But B is that I want to be able to slap TUI applications, right, onto existing systems, right, without having to do any major rewrites about how they communicate with each other, right?
Yep.
I want to be able to say I have this server that is running. Let's say we have a like I don't know, like OBS overlay server, right, that does things, right?
Yep.
And I want to be able to, without much work, right, just add a Minty application to it that runs parallel to the actual server, right? Has access to the server, can sort of send messages into the server and get messages out of the server, right? All in the
Yeah.
same binary, right?
That's
And
I hadn't considered a use case like that, but that is super cool. Like I can
I
like
think so.
imagine building like some debugging utilities
Yes.
that are accessed. One of the guys at my work, Zach Balin, just released a like SSH util to inspect OCaml processes that I'll have to share with you. And this seems like it could be like a good front end to that on top of it. It's very cool.
Exactly. Yeah. Ultimately, I would love to build um, some sort of like interactive, uh, let's say, like a REPL, if you want to call
Yeah,
it
yeah,
that,
yeah.
right?
I was actually so Ryan Winchester was streaming Elixir as he does, uh, and he had pulled up the Elixir REPL and was like, you know, evaluating and editing values in real time of his processes from the Elixir REPL. And like, I
Yeah.
mean, I've been a fan of OTP for a long time. I've written like a couple small things for work a couple years ago in Elixir, but never really got into using like Gen servers and stuff. But I think OTP is one of the coolest pieces of software ever built. And like I think it's super slept on. And as you said, a lot of companies, it's the secret sauce under the covers that no one talks about. A lot of these questions I've been asking you, I obviously like know the answers to, but I had not considered the actual use case of connecting Mint Tea to running um, Riot applications to interact with. That is super cool, super exciting.
I think like for the I don't know what to call them, the people that say like, oh, but you couldn't do the same thing without it. Yeah, you can do the same thing without embedding sort of the Minty application into the runtime, right? But you need to expose a lot of stuff. Like we were talking about building a dashboard, right, for Riot, like a web dashboard,
Yep.
so you can see processes and stuff like that. And you can do that, but you need an API, right, on top of Riot on every Riot application. Maybe you don't want that, right?
Yep.
And you need to build a front end and everything. And it's just like a magnitude an order of magnitude bigger than just saying like I'm gonna have a very tiny TUI application, right?
Yep.
That is running right there, so I can just like seek up or send a custom like you know kill signal to the app, and then it just starts running the thing.
Okay, so we're looking at the interface file for the entry point to Minty. Do you want to just talk us through what we're looking at here?
Yeah, absolutely. So from it's actually a very small file. If you want to scroll all the way down, you'll see I think it's like maybe 40, maybe 50 lines. Yeah,
Yeah, 48 lines.
yeah, 48 lines. So it's pretty small considering the formatting and whatnot. We have usually we read these files from the bottom up in OCaml because that's how
Yep.
things are defined, right? So at the very bottom you have a function called start. Start is the function you run when you want the application, the Minty application, to be your application, right? To take over everything. You pass it an apt, which is a tiny module that is defined above, right? And then you also pass it the initial model, right? The first sort of state that you want to use. And the reason we put that separately is that we want to be able to initialize the application in different states, right?
Yep.
For testing purposes and so on. So that would be like the basics. If you want to start your app, you do start and you pass in the model T, and that's it, right? Now to create an app T, you can call the function app, which is in line 40, right? And this is the structure of the entire Minty application. An initialization function, as we went before, an update
Yep.
function, right? And then a view function, right? Now the other two things that are provided by Minty are the events and the commands.
Okay.
Everything else is yours, right? Like how you render, up to you. Like how do you put your string together, right?
Yep.
What model you use, up to you, and so on. So you can choose to do nothing. You can choose to quit the application, right? You can choose to show or hide the cursor, enter, exit full screen, right? You can give it a sequence of commands that will be run in order, or you can set a timer, right? And we here is where some of Riot leaks out when
Okay.
we're saying like if you want to set a timer, we need a way of identifying that timer for you, right? So you can when you get the event, the timer was triggered, then you can match it up with you know the timer you set. But we don't have the ability, for example, for custom commands yet, right?
Okay.
You essentially have those commands, and those are mostly enough
Cool.
for now. Now, complementary to commands are the events, which are the things that the runtime says, hey, this is what's happening. And the events are four right now, and they will expand with time. The first one is key down, which includes a key. and the
Yep.
key type is defined there as well. You have some common keys as actual variants, so it's pretty easy to discover what you can match on. And then you have a key, right? One variant that says key that it just includes whatever was typed. And
Cool.
we're doing this instead of having an enum with like all of the alphabet, right? Because we don't know what alphabet you're on, and it's
Yep.
yeah, it's easier to just say like, okay, just put the string that you expect here, and you will match against that, and that'll be it, right?
I've heard you uh, talk quite a few times on both stream and Twitter that um, kind of at a high level, like don't let type safety get in the way of DX. Like obviously, as
Yes,
functional programmers and lovers of OCaml, like we value type safety above most other things. However, there is diminishing returns. Is
yes,
this kind of an example of what you mean here?
I think it is. I think this is a good example of because this interface was even less typed at the beginning, right? It used to be key down and then you get a string and you have to match and shit like that, like brackets, cape the string.
Yeah.
But it made sense to have some common things as essentially typed constructors, and then some other things that we don't know about, right? We just say, okay, here's a key and so on. So like the values that we are pursuing with Minty, with Riot, with the entire Riot stack really, are that we want type safety and as much type safety as we can get without compromising the developer experience, right?
Yep.
Without compromising the clarity. There's been a lot of places in the Riot stack where I've had to do some tricky things with GATs and first class modules, right? That
Yep.
have been actually for developer experience, so that the developer experience is better on the other side.
So what is a frame? How do we use it? And when we also want to use a timer?
Absolutely. So a frame is an event that you will receive, right? Every time something will be rendered on screen.
Okay.
So you can use a frame and to drive an animation, for example. And I
Okay.
think we
Gotcha.
can run if you want one of the examples, or maybe even just go to the GIF.
So this would be a good example. Every time this is changing, we're getting a frame event. Is that kind of the high level?
Exactly. So every time the renderer decides to render, right, you can configure the FPS as well.
Okay.
We actually will get an event, and based on that event, you can update your state, and then you create um, a
So
new
are
view
we in
that
a
will be
render
rendered.
loop here that's constantly re-rendering at some FPS, or is it more of a system where it only renders when like an event is dispatched?
The moment the frame is triggered by an FPS timer, right? Internally, we have a timer that says the FPS. So if you that's an interesting point. Maybe you want to make this more configurable. So you can have something that renders once and just stays there until something happens, right?
Like a
Or
static.
exactly. We can also do some things about the rendering so that even though we trigger a render effect, if we're about to re-render the same thing, we do nothing, for example.
Hmm. Clever. Yeah. Well, there we go. Now we have a
Okay,
progress bar.
that actually is doing something. Yeah, that works. Look at that. You can see the world is spinning as well here.
Yep.
That is a text-based sprite. It's a very early stages for Riot and Minty as well, so we do have some bugs to fix.
Cool. Yeah, I definitely a big part of my intent on this is to help contribute back to Mint Tea and make it better as we go and fill in the gaps for uh, at least the features we need on Create Melange App. So is it fair to say that we're going to end up in Mint Tea designing like our state of the application to be essentially updated by these events? That's going to cause the terminal to re-render and then just over and over again. Is that generally how it goes?
Yes, exactly.
Um, might be getting ahead of myself here, but is it all one top level state, or can you have multiple kind of slices? Is what they call it in Redux land, or is it? Can you like compose pieces of state that have like individual runners on it, or how does that work?
Right, right. That's an excellent question. So Minty is designed to have a single main application, right? Because there is a single render loop essentially. However, what do you do in that render loop is completely up to you. So if you want to have multiple applications, right, multiple tiny things that have the same shape, you can do it, and you can get them together. I would be great to look at one of these things. Yeah. So usually an application has a state, which we normally call like type model or type S. You have an initialization command that says like, what are we going to do when the application boots? Usually it's noop, like you do nothing. Sometimes you want to go full screen, for example, right? We do have an update function that every time an event happens will be called with the model and will update the model, right? And usually the update function returns the model, but also some command, right? Like you want
Hmm.
the model to, let's say in this case of a counter, update the internal integer that is the counter, but also do nothing unless if you go into line 17 we have there, right? The event key down key q is pressed, right? Then the model stays the same, but the command will be quit because we want to tell Minty, hey, we're ready to close up the application, right?
Gotcha.
And this model that comes out of the update function will be shoved into the view function, right?
Okay.
And the view function is responsible for taking the model and turning that into, essentially we're in a terminal, so it's just a string, right?
Yeah, yeah.
So yeah.
Very cool. This feels super familiar as someone who's worked with like React and Redux for a long time.